So today we'll be finding the missing values of y equals mx plus b. So we'll be finding maybe an m, maybe a b value, maybe even using x and y. So you're going to be able to write an equation from just 2 points, which seems like it's awful hard to do given the fact that we've been graphing these and using a coordinate plane, but that isn't always necessary. So think of this as think of this as a mystery in which you're trying to identify clues, in which you're trying to determine what you're missing and what we're trying to solve for, just like Scooby-Dooby-Doo. So let's first kind of give this some background, all right? Points are going to be very important to us today because points that are on the line make the equation true. So we're going to try to figure out which one of these points is a solution or an answer to the equation. Now let's not forget that points are variables, all right? It's an x and a y. So let's do it one at a time. Let's take the equation y equals 3x minus 8, and let's substitute in 5 for x and 7 for y. So 7 goes in for y, 5 goes in for x. And when we get this far, there's no solving, it's just simplifying. So 3 times 5 is 15, and then do 15 minus 8, and we end up at 7, which is true because 7 equals 7. So that verifies the point 5, 7 is an answer to this equation, which means we can use it to find out other things about this equation. Let's see if the same thing works for the point -3 and -1. All right, this one right here. I'm going to go back to the same equation, same line. I'm going to substitute in -1 for y and -3 for x. There we go. Minus 8. Now we're not actually solving an equation, we are just simplifying an equation. So to do that, we want to multiply first. -9 minus 8. At first glance, you might just want to think to put -1 equals -1, but that is not the case. We have -9 minus 8, which is -17, which is not equal to -1, so this is false. And therefore, you would not be able to use that point to do anything with that line. It's not a solution, not an answer, it's no good. It's only points that are on the line that work for us, okay? So where are we all going with this? Let's show you. If we were given the following clues, a line with a slope of 7 that passes through the point 4, 3, and we are asked to find the y-intercept. Well, let's put on our Scooby hat here, all right, and see if we can figure out the missing information. Well, let's figure out first what we have. We have a slope of 7, which means the m value is 7. We are given a point that's on the line, so that means this x and this y are good to use, and we're solving for the y-intercept, which is the b value. All right? Let's not forget that this is all about using the equation y equals mx plus b. Okay? So if you're a good detective, you figure out all the clues and then you work from here. So those are all the things that I have to work with. Now what do? Substitute, right? Put in the numbers for the letters. So the y value is the 13. The m value is 7. The x is 4, and I'm solving for y. Now, we've been down this path before. We have an equation with one variable, which means pull out your solving steps and you can find out what the missing number is. 7 times 4 would happen first, and we'd get 28. We'd have to move the 28 from one side to the other, so we would have to subtract 28. And in doing so, we'd end up with -15 equals b. So, given just the slope, and given one point, we were able to come up with the y-intercept, which doesn't seem like a big deal, but here's where we're really going with it. Question didn't ask us to do this, but what we're really doing is trying to come up with the equation, which we can then do lots of things with. So y equals always the slope, then followed by x, and then -15. So there you go. There is a way to come up with the entire equation just from knowing the slope and knowing the point in which is on the line. Not seeing any questions. I hope this is going well. And again, quality over quantity. I usually do a couple of normal examples, like a couple of these examples in class when it's normal. But now that we're home, I'm kind of shortening these up. So we're going to go right to the next style, which is very similar. This one gives us a graph. Okay, so let's see if we can figure out the clues and solve the mystery to this one. Find the equation of the linear function shown in slope-intercept form when the y-intercept is not clearly stated. You're like, Mr. Petrie, we've already done this year. I just simply count the rise and run and see where it crosses the y-axis. But this time, guess what? That y-axis is a problem. It's not at a whole number. It's not at 1 and it's not at 2. It's somewhere in the middle of 1 and 2. So I'm going to have to come up with the y-intercept a little bit differently. In order to do this, let's figure out what we know. We know a couple of points on the line, and that's going to be important. This point right here is 1 to the left, up 2. So -1, +2. This point right here is 1, 2, 3, 4 to the left, -4, and up 3. So those 2 points will be helpful. What else do we know? We know the slope of the line, right? So we can count the rise and the run from this point to this point. It's going up 1 and then left 3 would be -3. So let's go ahead and make a list of our clues. We've got a slope that is -1/3 and we've got 2 points. Now 2 points is actually too much information. I only need one of those points. So when you're given the choice between which one, I always go smaller number and a positive if possible. Well, we don't have positive numbers, at least both of them, but we do have small numbers. So I'm going to take the points -1 and 2, which is my x value and y value. And so what I've come up with is 3 numbers. 3 numbers that I can successfully substitute into this equation that is all letters. So now let's go ahead and just substitute all the values I have appropriately. 2 goes in for y, -1/3 goes in for m, -1 for x, and then plus b. And so from here, just go ahead and solve like we did. We've got negative times a negative, so that's simply positive. Now that wasn't all that bad. And then we got to solve for b by subtracting 1/3. Now it's not a whole number, I get it, but that doesn't mean it's difficult. So we're going to subtract 1/3, and in order for us to think about this, we got holiday season coming up. Maybe people are going to make some pies or make some delicious desserts, and think about 2 whole pies. All right, maybe it's apple or pumpkin, that's your favorite, and somebody slices them up into 3s. All right, so each pie is into 3 slices, and somebody eats 1 of those slices. Well, that means you still have 1 whole pie left. Nobody touched that. They took 1 slice out of the other pie, which had 3 slices, so that means 2/3, 2 slices out of the 3 are left. And so there is your b value. Okay? If you have questions about how to subtract fractions, let me know. I could show you how to do that on your calculator. Now, the real thing we're trying to figure out is the equation. So let's go all the way back to the beginning where y equals starts it. We want to put the slope in for m, and then we want to add the y-intercept of 1 2/3, which makes total sense because this right here is a little bit more than 1, but less than 2, and 1 2/3 falls right. So for this next one, very similar, but the clues have changed. Scooby-Doo's on to another mystery. We're going to find the equation of a line in y = mx plus b form, that hasn't changed, that passes through 2 points. So that's all they're going to give us is simply 2 points. No line, no graph, just where it's located. Is that enough? Let's find out. Well, this point always comes as x and y, and this point always comes as x and y. So they've given us x and y. But we don't know m and we don't know b. But just last class, I showed you the slope formula, how we can come up with m. So if you weren't in class or if it didn't make sense, here's one more chance to see a live lesson of how to do this. The slope formula, just something you're going to have to know, is y2 minus y1 and x2 minus x1. So you subtract the y values, you subtract the x values. Where do I get the 1s and the 2s? Because the numbers, or sorry, the variables probably make sense, right? X and y. Well, this is the first point, so we call it x1, y1. Simple as that. This came second, so let's call it the second point, x2 and y2. From here, substitute it into the formula for 17 minus 5, y2 minus y1, and then it's 5 minus 2. I'm guaranteeing, folks, that if you label your points x1, y1, y2, x2, you will get this more right than wrong. It will make it so much easier just to make that simple annotation. 17 minus 5 is 12. 5 minus 2 is 3 for a grand total of 4. So you have found the m value to be 4. And guess what? We're doing the exact same thing we just saw in the last slide. So here's our clues. We've got a slope, we've got a point, we actually have 2 points, and I'm going to go with the lowest numbers. Low man wins here, so I'm going to substitute into this formula. I'm going to put the 5 in for the y value, 4 in for m, and 2 in for x, so that I can solve for b. After that, it's a very simple equation where we would multiply first and get 8, and then do the opposite of positive 8 and subtract 8 on both sides. So we'd end up with negative 3 equaling b. And there you have it. You've done everything you've needed to do to come up with the equation of the line, which would be y equals, so you'd have the 4 for the slope, so 4x minus 3. Last one. And oh boy, it's got words. Yeah, that's all right. We got this. So hopefully we're ready for this, and hopefully you realize that I'm going to apply this to the real world in some way. What we're doing is could be used in a real life situation. So here's how you could use this information. A car is traveling along a straight road. Good thing it's straight, because that makes it linear. And after 1 hour, the car is 72 miles from Chicago. After 3 hours, the car is 188 miles from Chicago. Let's determine an equation for the distance d that the car is from Chicago h hours if the relationship between d and h is linear. Ding, ding, ding. What are they telling us? Is when we read this question, you want to make sure you're getting all of the clues. And one of the clues in this are the hey, you got me. Nice job. One of the clues in this is how far they are at a specific time. So after 1 hour, 72 miles, and after 3 hours, 188. So how are we going to use this information? Anytime you have 2 points, you can find the slope, whoa, that's a crazy y, of these 2 points by using this formula. Okay? So let's go ahead and substitute the x values and the y values. Don't forget to annotate. This is the first, this is the second. So 188 y2 minus 72 and 3 minus 1. Don't make this more difficult than it is. 188 miles minus 72 miles is 116, and 3 hours minus 1 hour means 2 hours. Now we'd rather get it down to a unit rate. Instead of out of 2 hours, let's make it out of 1 hour by dividing. So this would be 58 miles in 1 hour. So that's pretty good, 58 miles an hour. Maybe they're not on the highway, but they're going pretty quick. So we've gotten the m value, and now we need to find the b. Well, let's take what we know. We know this equation has to be used. We have the slope. Now we got to pick a point. I'd say this one would be the easiest one to come up with, or to use, because it's the smallest. So 72 for y, 58 for m, 1 for x, plus b. What does this really mean? If you travel 58 miles and you go for 1 hour, you're going to go 58 miles. All right, so that's pretty simple. Subtract 58. So if I was 72 miles away at 1 hour, but I'm only going 58 miles an hour, I must have had some kind of head start. and that head start was 14 miles. Okay, so